Good morning, students. So in the last class we studied about the Barn parameters. Okay, that regards about hybridization. So in the today's class we are going to start with the last area of this chapter, that is MOT, molecular orbital theory. Okay, so what is this molecular orbital theory tells about? So listen, first initially I'll explain postulates. Later I'll explain the structure of the molecules based on this MOT. Okay, so the first one is the postulates of the molecular orbital theory. As I told you, all the postulates are very important for 3 marks. Okay, the first one is the electrons in the molecule are involved in bonding. Electrons in the molecule are involved in bonding. Okay, so you may take are involved in molecular orbitals also you take. Or the electrons in the molecule are present in molecular orbitals also you take. You just change this. Are present in molecular orbital. First one. Later I will explain the postulate. What are those? The molecular orbitals are formed by contributions of atomic orbitals of comparable energies. Okay, that is the second energy and also symmetry. Both. Okay. Next. Third one is atomic orbital is monoatomic, whereas molecular orbitals are polyatomic. Okay, next. The number of molecular orbitals formed is equal to the number of atomic orbitals combined. Okay, next. The molecular orbitals formed are of two types. One is bonding molecular orbital. One is bonding molecular and another is antibonding molecular orbital. Bonding molecular orbital and anti-bonding molecular orbital. Okay. Next, the the bonding molecular orbitals have lower energy. Okay. Molecular orbitals also filled according to alpha principle, Pauli's exclusion, and Unslur. Okay, so students, these are all the postulates or salient features of molecular orbital theory. Listen. So here, listen, whatever we explained, that may be a Lewis concept, maybe a valence bond theory, VSCPR theory, and hybridization. Everything is depends on only one atom, like central metal atom. We are considering for CH4, we are considering only the configuration of carbon. We don't bother about what is that hydrogen. CF4 also. We are considering only about the concept, electronic configuration of the carbon. In BF3, configuration of boron. In H2O, configuration of oxygen. So whatever the theories we explained before are completely depends upon what? Only one atom. So that atom and the orbitals of that atom undergoes hybridization, or they mix up with each other, they form hybrid orbitals. Or the lone pair of electrons, they share between each other and they form bonds. They form lone pair electrons. Okay, so that is what we are particularly concentrating on, only one atom. Okay, but now it is not like that. The next theory introduced is what? Molecular orbital theory. To overcome what? We need to give the preference for all the atoms. Even the bonded atom, even the central metal atom. Understood? So both are having the main features. The first one is the electrons in the molecule are present in molecular orbital. So whatever we explained, that is atomic orbitals like s orbital, p orbital, d orbital. Okay, those are all what? Atomic orbitals. So those atomic orbitals where the electrons of atom present. Here we are considering what? Particularly molecule. So electrons of molecule are present where? In molecular orbitals. Means how the molecular orbitals will form? By combination of the atomic orbitals. Remember here, the molecular orbital formed are of two types. One is bonding, another one is anti-bonding, I told you. So for example, and this one, the atomic orbitals is this one. The molecular orbitals are formed by contribution of atomic orbitals of comparable energies. Means, for example, here assume 1s orbital is there. Here also 1s orbital is there. Two atomic orbitals combine with each other to form two molecular orbitals. How many atomic orbitals will form? Sorry, will combine, that much of molecular orbitals will form. Are you getting? Here 1s orbital, 1s orbital of both atoms. Then here it is, one will form. Okay. So one is bonding molecular orbital, another one is anti-bonding molecular orbital. Bonding molecular orbital is represented by Rn2 by this is sigma s. This one is sigma star s. Means the bonding is without star, represented without star. antibody is represented with star. Are you getting? So means if two atomic orbitals overlap, then two molecular orbitals will form. If three atomic orbitals will overlap, then three molecular orbitals will form. If four atomic orbitals not overlap, combine. If four atomic orbitals combine, then four molecular orbitals will form. You may write another one here. The number of molecular orbitals formed is equal to the number of atomic orbitals combined. I think okay, here it is. The number of molecular orbitals formed is equal to the number of atomic orbitals combined. How many atomic orbitals will combine? That much of molecular orbitals will form. So these are the fast ones. Same the electronic configuration fill-up also takes place in the same way. Okay. So to that, initially I will give two configurations here. So students, I clearly explained. So in p orbital, one is the sigma bond forming axis, another two are the pi bond. Means this is the x-axis. You assume this is px, py, okay, anything, pz, px, py, pz, anything. So three different angles are there. So three different planes are there. Among them, this one is considered as a main axis. Means pz always forms sigma bond, this x and y always forms pi bond. Because while writing, we know this one is taken as the main axis z, this one is x, this one is y. This is in present in horizontal. Means along axis it is present. So this z is considered as the main axis. So this will form sigma, this will form pi. X and Y form pi bonds, sigma Z will form sigma bonds because Z is taken as a main axis. In p orbital, there may be a possibilities of three bonds. One is sigma, two or pi. Okay. So why I am telling this? Because in this molecular orbital, we are considering individually px and py orbitals. Okay. Listen here, two configurations are there. Initially, right? The first configuration up to atom, I write hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Only these molecule follows the following configuration. So the first one is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py sigma 2pz. After that, you just write commas here. Okay. Next, pi star 2px, pi star 2py, sigma star 2pz. Okay. This is the configuration for what? This hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Why? Because up to nitrogen, we know orbitals are like this. 1, 1, 1. So the p orbitals are not completely filled. Okay. So that's why this configuration is followed. Later I'll just only one change is there. So students, how to write this? If I consider hydrogen, okay, initially I will write the diagram, later I will explain. So listen, this is 1s orbital, because here 1s, 2s, 2p orbitals are there. This is 1s orbital. This is 1s, this is sigma 1s, this is sigma star 1s. This is of what? Same energy levels of two molecules. 1s completed. Next 2s. How many orbitals are there here? Two orbitals. One 2s orbital from one atom, another 2s. Assume this one is AB orbital. One orbital of A, one orbital of B combine with each other. So they form molecule AB of, and they are forming a bonding and an anti-bonding molecular orbital. Okay, so this one is sigma 2s, this is sigma star 2s. So remember students, why I am considering sigma here means s orbital always forms sigma bond. Okay, next one is what? P orbital. How many p orbitals are there? 3. Okay, here also 3. So here 3 orbitals are there. Here also 3 orbitals are there. 3 plus 3 combined with each other, then how many molecular orbitals will form is 6. Because 3 atomic orbitals of A combined with 3 atomic orbitals of B. Number of atomic orbitals combined is equal to number of molecular orbitals produced. Okay, so that is 3 plus 3, 6 molecules. Among those, 3 are antibonding, 3 are bonding. So here, which one will count first? Pi 2px, pi 2p. Consider here, later sigma 2p. Later pi star 2px, pi star 2p. Later sigma star. Are you getting how to write? Okay, so listen, why I am writing here? This is the increasing order of energy. 1s has least energy compared to 2s. 2s has least energy compared to 3s. You know, this is increasing order of energy level. That's why I am writing 1s here, 2s here, 2p here. Later 3s, 3p, same. So here, okay, this one is pi 2px, this one is pi 2p, right? This is sigma 2p set pi star 2px, pi star 2py, sigma star 2p set. This is how to write the molecular orbital. Are you getting it? So here the complete molecules are involved. So this type of configuration for which molecules? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Next remember, this is the electronic configuration of the molecular orbitals. So whatever we wrote before, that is 1s2, 2s2, 2p6, that is electronic configuration of atoms. This is electronic configuration of a molecule. I'll give a simple idea to you how to write the configuration, how to count the bond order, everything. Listen. So from this we came to know this is the molecular orbital, this is how the bonding takes place, and this is the electronic configuration. Next, finding out of the bond order. Bond order means number of bonds. How many number of bonds are present? So listen here. Bond order is equal to, you can take bond order is equal to bonding molecular orbital minus anti-bonding molecular orbital divided by 2. Means the electrons present in bonding molecular orbitals, this, minus electron present in anti-bonding molecular orbitals. Anti-bonding molecular orbitals means which are written in stars, divided by 2, that will give the bond order. Understood? This is how to calculate bond order. Next, another one is whether it is paramagnetic or diamagnetic. If the electrons are singly filled, then paramagnetic. Okay, if it is completely filled or paired up, not completely filled, you take single electron means paramagnetic. Paired electrons means diamagnetic. You know, this is single electron. This one is paired electron. This is paramagnetic. This is diamagnetic. Okay, so listen. Here these examples are there. I'll explain by taking one of the example here. That is H2 molecule. Okay, initially what you have to do? So this is one hydrogen. This is one hydrogen. You just write the molecular orbitals here. How to write? This hydrogen atomic number is 1, configuration is 1s1. Only one orbital is there. So just write one orbital here. No need to write. Now you very big necessity just combination of the atomic orbitals. Okay? How many electrons are there? In one hydrogen only one electron. Here also only one electron. If two atomic orbitals of 1s, 1s combine with each other, how many molecular orbitals will form? Two atomic orbitals are combined with each other. Then how many molecular orbitals will form? How many? ಎರಡು atomic orbitals combine ಆಗ್ತಾ ಇದೆ. According to the postulate, number of molecular orbitals produced is equal to how much ಆಗಿರುತ್ತೆ? ಎಷ್ಟಾಗಿರುತ್ತೆ? ಎಷ್ಟು atomic orbital combine ಆಗಿರುತ್ತೋ ಅದಕ್ಕೆ equal ಆಗಿರುತ್ತೆ. ಎಷ್ಟು combine ಆಗ್ತಿದೆ? Then molecular orbitals ಎಷ್ಟು ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ಎಷ್ಟಾಗುತ್ತೆ? 2. One is ಯಾವ ತರ 2 orbitals ಫಾರ್ಮ್ ಆಗೋದು? Which type of orbitals will form? Type. Here 2 orbitals will form. I agree with that. Which type? So this one is bonding molecular orbital, that is sigma 1s. ಇಲ್ಲಿ ನಾನು ಆಲ್ರೆಡಿ ಬರ್ದಿದ್ದೀನಿ. Next anti-bonding ಅಂದ್ರೆ sigma star 1s. So niಮಗೆ means bonding molecular orbitals has less energy compared to anti-bonding. Okay. So in the last postulate I told you. So these atomic orbitals, even the molecular orbitals, even the electron configuration fill-up takes place according to Aufbau principle, Paulus distribution principle, and also Hund's law. Means initially the lower energy orbitals fill-up takes place first, followed by higher energy. Here one electron of this atom is here. Next, this one is also paired up. Initially, the lower energy completely fills, followed by higher energy. Okay, if anything, if in case here 3 electrons are there, 1, 2, 3. Are you getting? So now, this is the molecular orbital diagram for hydrogen molecule, H2 molecule. Next, MOT configuration, electronic configuration. How many orbitals are involved here? 2. One is sigma 1s, another one is sigma star 1s. In sigma 1s, how many electrons are there? Here, this is the sigma 1s orbital. How many electrons are there? 2. In sigma star 1s, how many electrons are there? Nothing, means 0. This is the electronic configuration of H2 molecule, MOT configuration. Okay, this is molecular orbital theory. This is the configuration. Next one is bond order. Okay, how to calculate bond order? Electrons in bonding molecular orbital minus anti-bonding molecular orbital. Bonding molecular orbital ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ? 2 ಇದೆ. Anti-bonding ಅಲ್ಲಿ ಎಷ್ಟು ಇಲ್ಲ? 0. Divided by 2. 2 by 2 means 1. Means bond order is equal to 1 here. Means the molecule here is hydrogen, single bond hydrogen. So next one is magnetic property. These are 5 points you should write. So whether this is paired up or simplified? Paired up means this is diamagnetic. These are the points you should write. This is the very important theory to study about the molecular orbitals. Are you getting? Initially, writing the configuration. Each side we are writing the configuration of the molecule. We are combining the molecules, atomic orbitals. Then we will get molecular orbitals. Then filling up of electron takes place. This is molecular orbital diagram. Once we know that, then we need to write the configuration. Which configuration? This configuration. And ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಒಂದು ಹಿಂಟ್ ಕೊಡ್ತೀನಿ ನಿಮಗೆ. ಇಲ್ಲಿ ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೋ, ಓಕೆ, ಎಸ್ ಆರ್ಬಿಟಲ್ ಇದ್ರೆ 2 ಮಾಲಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ಸ್, ಒಂದು ಎಸ್ ಆರ್ಬಿಟಲ್ ಇದ್ರೆ 2 ಮಾಲಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ಸ್, ಒಂದು ಸಿಗ್ಮಾ ಒಂದು ಸಿಗ್ಮಾ ಸ್ಟಾರ್. 2s ಇದ್ರೆ ಸಿಗ್ಮಾ 2s ಸಿಗ್ಮಾ ಸ್ಟಾರ್ 2s, 3s ಇದ್ರೆ ಸಿಗ್ಮಾ 3s ಸಿಗ್ಮಾ ಸ್ಟಾರ್ 3s, 4s ಇದ್ರೆ ಸಿಗ್ಮಾ 4s ಸಿಗ್ಮಾ ಸ್ಟಾರ್ 4s. ಒಂದು ಆರ್ಬಿಟಲ್ ಇದ್ರೆ 2 ಮಾಲಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಪಿ ಇತ್ತು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಓಕೆನಾ? ಸೊ ಪಿ ಆರ್ಬಿಟಲ್ ಇದ್ರೆ ಒಂದು ಸಿಗ್ಮಾ ಪಿ ಝೆಡ್, ಪೈ ಪಿ ಎಕ್ಸ್, ಪೈ ಪಿ ವೈ. ಬಿಕಾಸ್ ಪಿ ಆರ್ಬಿಟಲ್ 3 ಇರುತ್ತೆ. ಇಟ್ ಮೇ ಬಿ 2p 3p ಏನಾದರೂ ಆಗುತ್ತೆ. ನೋಡಿ, ಸಿಗ್ಮಾ 2p ಝೆಡ್, ಪೈ 2px, ಪೈ 2py. Are you getting? Sigma star 2pz, pi star 2px, pi star 2py. P orbital. If you take instead of 2, if you take 3p orbital, sigma 3pz, pi 3px, pi 3py. P orbitals means we don't bother about 3, 4, 5. Okay, those are the valence shell configurations. Later I will explain. Okay, we are considering mainly what? The valence p orbital and s orbital. If s orbital is there, only sigma. P orbital is there, pi sigma. Okay, this is hydrogen molecule. Similarly, if you consider helium. Helium atomic number is 4. Configure helium 2. Helium molecule, if they said means helium 2 we need to take 1s2. So here same, one helium is here, another helium is here. This helium also consists of 1s orbital with 2 electrons. This is consists of 1s orbital with 2 electrons. If 2 1s atomic orbital combine, then how many molecular orbitals will form? 2. One is bonding, another one is anti-bonding. Remember that. You need to okay. So students, here this is sigma 1s, this is sigma star 1s. Here initially lower energy, 1 electron fill up takes place. From here also 1 electron. Then how many electron left? Again 2. So here it is 3rd, 4th. Now the configuration, MOT configuration. How to write? The sigma is there, 1s, sigma star 1s. How many electrons are present in sigma 1s? 2. In sigma star 1s? 2. Next, bond order. Bond order is equal to how much? bonding molecular orbitals. 2 electrons are there. In antibonding, 2 divided by 2. 0 by 2 means 0. Means there is no bond between He2 molecule. In hydrogen, one bond is there because bond order is 1. In helium molecule, bond order is 0. Means helium cannot be bonded. Bond formation agula. Why? Because they have stable configuration. You know that noble gases have stable configuration and they are inert, they do not combine with any other. And remember, this is also completely filled, this is means paired up. Then it is diamagnetic. This is how to write the molecular orbital diagram for the respective. And the most important questions often they ask is why helium molecule is unstable. Why unstable? You have to write this diagram, you need to write this configuration, you have to show bond order 0. If there is no bond means that there is no existence of a molecule. Understood? Okay. So this is all about that. So students, you just do it for lithium, beryllium and boron yourself. Carbon and nitrogen I will explain in the next class. Lithium, beryllium, boron. Understood? Okay. So follow this diagram and this configuration. How to write the configuration? So initially you write completely this. I will consider how many electrons fit up. Listen here. Here what I explained is sigma 1s. Sigma star 1s. If 2s orbital is there, you can take sigma 2s up to this you have to take. Including this and this. If 2p is there, then this and this. ಅರ್ಥ ಆಗ್ತಿದಲ್ಲ ನೀವು ಟ್ರೈ ಮಾಡಿ ಬಂದಿಲ್ಲ ಅಂದ್ರೆ ಸೇಮ್ ನಾನು ನಾಳೆ ಮಾಡ್ತೀನಿ lithium beryllium boron try to yourself because this one is consisting of 2s orbital, this one is 2p. I can see whether you can do it or not. Okay, in the remaining molecules we will discuss in the next class. Thank you.